Welcome to our YouTube channel. I am your instructor Syed Zakaria. Today we are diving into the exciting field of electrical engineering with a focus on circuit analysis and design. In this course, you will learn how to analyze and design different types of circuits from simple resistive circuits to more complex circuits with capacitors, inductors and filters. You will also study network theorems, transient response analysis and frequency response analysis which are essential tools for electrical or electronics engineers. Prerequisite of this course is electric circuits. Are you ready to unlock the power of circuits? So let's get started. Starting from a question, why we study and design electrical circuits? The answer is circuits are basic building blocks of any electrical or electronic component. They are designed to perform specific tasks to achieve some goals. As our world is moving towards electrical technology in every aspect of life, so this course is crucial for engineers working in the field of electrical, electronics, and computer engineering. Look at this simple circuit having 20-volt battery, 4 resistors of different values and a load of 4 ampere. Current is flowing from left to right in 2 and 4 ohms resistors while flowing top to bottom in the 10 and 20 ohms resistors. Let us see second diagram. In this animated diagram, capacitor and inductor are connected in such a way that both are sharing some energy present in them. To know their behaviors, grip of knowledge is required in this course. Take a look at learning outcomes of this course. First one is ability to analyze and design circuits. Second one is understanding of frequency response. And the last one is understanding of power transfer. Let us discuss key concepts of this course one by one with brief introduction. This topic includes definitions, workings, and applications of resistors, inductors, and capacitors, also written as combined RLC. This topic includes connections of RLC component with each other. This topic includes some basic Kirchhoff's law in electrical engineering such as KCL and KVL, etc. This topic includes nodal and mesh analysis of circuits that are based on KCL and KVL. This topic includes source transformation in circuits according to requirement. Source may be a current source or a voltage source delivering power to the circuit. This topic includes maximum power transfer theorem and power analysis in different types of circuits. Let's move further in key concepts. Transient analysis. It deals with the response of a circuit over a period of time defined by an engineer. Phasor domain analysis. It deals with the circuits in phasor forms and phasor diagrams. Laplace transform analysis. It deals with the Laplace and inverse Laplace transforms of circuits in order to analyze them. Pole zero diagram. It deals with the stability and nature of response of circuits designed by engineers. Frequency analysis. It deals with the Bode plot analysis in order to learn about frequency behavior of circuits. Network functions. It deals with the transfer functions of circuits and filter designed by RLC components. Next one is transformer analysis. It covers analysis techniques of transformers present in circuits. And the last one is power systems analysis. It covers powers related problems present between various circuits. Subtopics are real and complex powers, phase line voltage and phase line current, three-phase delta-wise circuits and their techniques. You can see animation of three-phase voltages that is generated by three circles of different radius. Now let us discuss some basic concepts of this course. Topic under discussion is sinusoid. So what is a sinusoid? Sinusoid is a smooth periodic signal. Sinusoid is expressed in terms of sine and cosine functions. As you can see, V equals to Vm sine omega t plus phi, where Vm is equal to amplitude of sinusoid, omega is equal to angular frequency in radians per second, phi is equal to phase angle. In this animation, a sinusoid signal is generated by a circle. Next topic is phasor. What is a phasor? A phasor is a complex number representing a sinusoidal function whose amplitude A, angular frequency omega, and initial phase theta are time invariant. As we seen earlier, V equals to Vm sin omega t plus phi is a sinusoidal signal. Bold V equals to Vm with angle phi. Here bold V is the phasor. In this diagram, a circle with mentioned dotted line of magnitude and phase is shown in real and imaginary axes. Now consider some phasor forms. A complex number can be written in polar form or exponential form. Z equals to R with angle phi equals to Re power j theta. A complex number can be written in rectangular form as well. Z equals to x plus j y is the rectangular phasor form. Euler's relationship provides the relationship between sine waves and complex numbers. E power j theta equals to cos theta plus j sine theta. This relation is also known as Euler's relation. Next topic is impedance. Impedance is a proportionality constant relating phasor voltage and phasor current in linear. The phasor IV constants are all in the form V equals to Zi. Here Z is the impedance. Impedance of three passive elements are given below. As I mentioned earlier that Z is the impedance of any passive component or element. First one is resistor. The impedance of resistor is R. Second one is inductor. The impedance of inductor is J omega L. Third one is capacitor. The impedance of capacitor is 1 by J omega C. Impedance Z is represented as Z equals to R plus JX. Here R is the real part and is also known as resistance. X is the imaginary part and is also known as reactance. There are two types of reactance, positive and negative reactance. The first one, positive reactance, is for inductors. The second one, negative reactance, is for capacitors. Here we go. Join us in unlocking the power of electrical circuits and take your engineering skills to the next level. Thank you for watching. Hit the bell icon for more exciting content. Allah Hafiz.